Okay, thanks to the magic of video, you didn't have to watch me erasing all that and drawing these graphs. Here on my left is the image of the z-plane. So the x-axis here corresponds to the real part of z, and the y-axis corresponds to the imaginary part of z. Over here we have the w-plane. The u is the horizontal axis, is the u-axis, and v is the imaginary part of w. We worked out that u was related to x and y by this formula, and v was related to x and y by this formula. What we want to do in order to draw a graph of this complex function in the best way that we can, given that we actually have to represent 4 dimensions somehow, is we're going to look at the images of vertical lines, and they're going to make curves of some description in the w-plane. And we are going to make images of horizontal lines, and they're going to make corresponding curves in the w-plane. And there's some properties that are preserved going from here to there that are going to be interesting and important. But let's just go ahead and do it in the most brute force way possible. I'm actually going to look at the grid points here. I'm going to number this one the first grid point. This is the second grid point. This is the third grid point, fourth grid point, fifth grid point, sixth grid point, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21st, 22nd, 23rd, 24th, and 25th. With this video, I'll have a table of data, pre-computed data, so we're not going to go through computation of the image of all of these points. I'm going to give you that data, but I'm going to plot all the data that I already have. But we will do one computation, and we'll do the computation for grid point number 1. So at grid point number 1, that's saying x and y is equal to -2, -2. It's the lower left corner of this thing, so that corresponds to -2, -2i. And we worked out that z squared plus 2z gave us a u which was equal to this and a v which is equal to that. So in that case, u and v, when you do the algebra, comes out to be -4 and 4. You can do it by hand if you like, but I actually did use a calculator. So all integers were good with that. So where does -4, 4 go on this? Well, the scale on this graph is different to the scale on that graph. It has to be, because some of the numbers that come up are quite a bit larger. So -4, 4 goes right here. So that's the image of point number 1. And I'd like to write a number 1 next to that, but the graph is going to get a little bit cramped, so I'm going to just leave the label off for the moment. All right, so point number 1 goes to -4, 4. Point number 2, that's this one here, so that's x equals -2, y equals -1. That goes to -1 and 2. So goes to -1 and of course, I realized that I made a mistake, and when I said -4 and 4, and I plotted -4 and -4. So in fact, it should have been -4 and +4 for the image of point number 1. Now don't worry about this little dot, because I was going to plot -4, -4 later, so I'll just leave that in. So this is point number 1. That's actually going to be point number 5. Okay, point number 1, -4, 4. Point number 2 goes to -1 and 2. So -1 and 2 is here. So we've done this one and this one. Now let's do this one. When we plug in x equals -2 and y equals 0, we get the point 0 and 0. Really? So when x equals -2, we get -2 plus 1 is -1 squared is 1, -1 gives us 0, -0 is 0. So u is 0. And when x equals -1v is 0. So we get the point 0, 0. Now this point number 1, 2, 3, 4, point number 4 gets mapped to 1 and -2. It's this one. It's exactly symmetric to the image of this one. And the fact that the map maps this one and this one to symmetric points over here is not a coincidence. Great. So I've mapped 5 points, and if I drew a line, this red line, through these 5 points, you expect that a line will go through these points. And in fact, that's exactly what happens. And what we get, if we did more points, is a curve that looks much like that. Not a very human way to plot images of lines, just plot a few points, but it's simple. And so we'll do that. Now, if we take the next line, something interesting happens. Every single one of these images is real. And that's because x is equal to -1. So x equals -1 means v is 0 for all of these images. Red line, what happens when at point number 6 gets mapped to -5 and 0. So I'm going to plot a little point right there. This one gets mapped to -2 and 0, so there. This one gets mapped to itself. -1, 0 maps to -1 and 0, so that's right there. This one gets mapped to the same point as this one. I'm going to draw it on the underneath of the axis, not because it is underneath the axis, it's really right on top of the axis, just to emphasize that there's 2 of them there. So if I draw a line, the image of this line, we get a line that comes down the axis, stops at -1, and then comes back along the axis. So sort of like this curve, but flattened and moved up a little bit. When we draw the image of this line, something surprising happens. We get exactly the same line as this one, but traversed in the opposite direction. So the point -2 and 0 goes to -4 and -4. So last time we went this way, this point gets mapped to this point. This point gets mapped to this point. This point gets mapped to 0. This point gets mapped to this point, and this point gets mapped to this point. So we have the same curve being the image of 2 different lines here. And you think about that for a little bit, and you realize, oh yeah, it's a quadratic. W is z squared plus 2z. If I go back from w to z, it's like solving a quadratic equation, and we'll see that. So for each one of these, there's going to be 2 roots going back. So yes, it's actually possible for one line to be the image of 2 lines on this one. All right, let's go on to the next one. We go on to this line. This is point number 15, actually. No, sorry, that was point number 11. This is point number 16. So this gets mapped to the point -1 and 8. All right, so we draw -1 and +8 is up here. Oops, pardon me, that's the keeping my color straight here. -1 and 8. This point gets mapped to 2 and -4. I've done it again. This point gets mapped to -1 and -8. And this one gets mapped to 2 and -4. This one gets mapped to 3 and 0. This one gets mapped to 2 and 4. So that's the symmetric image of this one. And this one gets mapped to -1 and 8. So those points are the same. So now we draw the image of this line running through these points, has to run through these points, and of course I'm extending these out in a way that looks sort of like parabolas. We don't know that they're parabolas yet, but we'll come to that. Okay, so we've done this one. Let's do one more curve. Point number 21 gets mapped to 4 and -12. That's down here. Point number 22 gets mapped to 7 and -6. Point number 23 gets mapped to 8 and 0. Point number 24 gets mapped to 7 and 6, 7 and +6. And point number 25 gets mapped to 4 and 12. Again, this line is going to get mapped to a line that goes through those points. That's the vertical lines. They get mapped into these bent lines. So what happens to the horizontal lines? We don't need to do any more computation. We've already done the computation at the grid points. We're just going to draw lines through different ones of them. So this 1, 2, let's go 1 to 6, and this is 11, and this is 16 and 21. So let's go from 1 to 6 to 11 to 16 to 21 and see what happens. And because this line is blue, I'll try to draw a blue line here. So 1 was this one, -4 and 4. 6 was -5 and 0. Where's -5 and 0? -5 and 0 is there. Oh, that was a point on one of the ones that collapsed. So it's a bit of a surprise that we're going this way, but there it is. And this one, 11, is -4 and -4. So we're going this way now. And 16 was -1 and -8. That's this one. And 21 was 4 and -12. So 4 and -12. Well, this isn't symmetric. We're going around this way, but I'm going to extend it. I'm going to say it's going to go out this way. And I'm also going to say that this line would go symmetrically if I extended it out here. If I did the computation of the points out here, I'd find that it was actually going to that one. So that's the bottom line. The next one starts at point 2, -1 and 2. So starting this one, -1 and 2, so that's this one. And again, it comes in and goes out again. So I'm just going to draw it. We're almost done because this line and this line have the same images as this line and this line. Again, that doubling up happens. But what about the image of this line? Well, every one of these points is real. Okay, so y is 0 here, so v is all 0. So we have to stay on the u-axis. And what happens is we come in all the way to the -1. It's the same place that we stopped last time, and we go back up again. So we have a similar family of curves, this way and this way. So we start with a net and we end with a net. This is called a conformal map. Well, it's conformal except at one special place, and that's the place where these things collapse. So this place here, this map is not conformal, but everywhere else.